is hashtag NPFS Maths. Okay. Today we're going to look at multiplication and division. What is multiplication? What is division? We're going to look at multiplying through arrays. We're going to link that to the 100 square and patterns. We're going to link it to bar models. And I'm sure, as Joe said at the start there, hopefully multiplication and division will become a lot clearer and a lot simpler after today's session. So first question, now you should have a pen and paper and you should be shouting out at home. What do you see on the screen right now? So tell me, what do you see on the screen? I'm going to ask Austin, what do you see on the screen, Austin?
4 groups of 3 dogs.
4 groups of 3 dogs. So there might be a different answer you have there. You might see 12 dogs, you might see 3 dogs plus 3 dogs plus 3 dogs plus 3 dogs. So you're seeing addition or your repeated addition of the same number. You might see 3 dogs in each of the 4 groups. So you're seeing 3 being multiplied by 4. Or as Austin said, you might see 4 groups of 3 dogs, which is 4 times 3 or 4 multiples of 3. So multiple groups of 3 is what we can see. Multiple means many or lots of the same thing. So next thing we're going to talk about sharing and grouping. So if you can see here, we have 6 cakes. I want you to imagine sharing those 6 cakes between 2 people. So imagine you had to share those 6 cakes between 2 people. What would you do? One thing I would just kind of split a line down the middle there and say, okay, one person is going to have 3 cakes, the other person is going to have 3 cakes. So that is us sharing 6 cakes between 2 people. We're thinking of division in the context of sharing. What if we had 6 cakes and we were going to put them into packets of 2 to give out to family or friends? So imagine you had 6 cakes and you're going to split them into packets of 2. What would you do here? Think about it. Well, there's 1 pack of 2, another pack of 2, and 3 packs of 2. So this time we've got 6 cakes, but we're splitting them into packs or groups of 2. So here we're thinking of division in the context of grouping. So what I want you to do on a bit of paper, or you can imagine it in your head, think of a picture that represents 3 times 5. So on your bit of paper or in your head, you can think of a picture that represents 3 times 5. I hope you're doing this at home. Even if you're sitting on your own or sitting with your parent, or you are a parent and maybe your child can't make it for some reason just now, have a go at this. So draw a picture that represents 3 times 5. Now here is the pictures that I have pre-prepared. You can see if you agree with it. First of all, I want to think, are you thinking of 3 multiples of 5? Or are you thinking 3 is being multiplied by 5? So if you're thinking 3 multiples of 5, you're thinking it's 5 plus 5 plus 5. Or if you're thinking of it as 3 is being multiplied by 5, then you're thinking of it as 3 plus 3 plus 3 plus 3 plus 3. So here is my picture. I actually think of that as 3 times 5, or 3 groups of 5. So I have a kind of picture roughly like that, or like that. Or if I was being really creative, I might want to put a context in it. So I could be drawing wee icons, emoji faces, or flowers or whatever, so you can put a context into it as well. And if you look at this picture here, so this is 3 rows of 5. I can see also that is a group of 3, or 1 column of 3. Then there's a second column of 3, third column of 3, fourth column of 3, fifth column of 3. So basically I can see that as 3 times 5, but I can also see it as 5 groups of 3. So here we can see, look, 3 times 5 is equal to 5 times 3. So that property about multiplication, that 3 5s are equal to 5 3s. And I just put a wee link here. This links back to all the subitizing that we were doing in the first couple of sessions. Now I want you to draw me a picture that represents 12 divided by 4. So I want you to draw me a picture, or think of a picture in your head of 12 divided by 4. How would you draw this out to someone? Or how would you draw it out yourself? Draw this out at home, think about it at home. 12 divided by 4, one way we can think of 12 divided by 4 is, well, 12 divided by 4 means 12 split into 4 groups. So I can get 12 counters or 12 dots or whatever it is I'm sharing, 12 biscuits, and share it into 4 groups. And we would see we end up with 3 biscuits in each group. So 12 divided 4 equals 3. So that is thinking of 12 split up into 4 groups. But there's another way you can think about 12 divided by 4. You can think of 12 divided by 4 as 12 split up into groups of 4. So how many 4s are in 12? So we're counting up in 4s. And again, we can think of biscuits. We've got 12 biscuits and want to put them into packs of 4 for your packed lunchbox or something. So here we could say, right, there's 4, 8, 12. So 12 divided 4, how many groups of 4 is that? We can see the answer is 3. So again, we're looking at division there in 2 different contexts. Either split up into groups, 4 groups, or into group sizes of 4. So the first task I'm going to get you to do, but not to just now, this is going to be on my website, so you can try this later. So there's the first task. And if you go to this website, www.countonus.org.uk/learning-together, and this will pop up, session 3, and if you hit this button here, that will take you to the tasks. Okay, so, but as I say, the task is on the previous slide, but you can do that at your leisure afterwards at 11 o'clock when we finish. Okay, so here's the big grid. I'm going to use the big grid here. What have I just done, Austin?
Put 3 into the big grid.
3 what?
Dots.
3 dots onto the big grid. Okay. So Austin said there's 3 dots here. Okay. Now you can draw this at home if you have a pen and a bit of paper, or you can just watch and listen. What I've done now, Austin?
Put 3 more dots.
I put 3 more dots in. So how many dots are there?
6.
6. Okay. What do they have now?
3 more dots into the big
3
grid.
more dots. How many dots is that?
9.
9. What have I done now?
Put 3 more dots in the big grid.
Now I want you to stop. I want you all to think, what are we doing here? So Austin, don't shout anything out, but what are we doing here? What am I doing here, Austin?
You're adding 3 every single time.
I'm adding 3 every single time. Austin, it's almost as if this was prepared as a script. What else am I doing? You might think, well, I'm counting up in 3s, or I'm skip counting in 3s. Basically, I'm drawing multiples of 3, or I'm drawing the 3 times table. How am I drawing the 3 times table? All I'm doing is adding on 3 each time. So it's very simple. So the 3 times table, or multiples of 3, is just like addition. It's just adding the same amount every time. How many groups of 3 are there right now, Austin?
4.
How many dots are there altogether?
12.
Good, so we can see 4 groups of 3 equals 12. How many groups of 3 now?
5.
5 groups of 3. How many dots?
15.
Okay, you guys can answer these questions at home as well. Don't shout this one out, but how many groups of 3 are there now? Shout out at home, type it in the box. How many groups of 3 are there just now? Listen to the question, how many groups of 3 are there? There are 6 groups of 3. How many dots are there? There are 18 dots. And I can keep going. How many groups of 3 are there now? There are 7 groups of 3. How many dots? 21 dots. And we could keep going now. There's 8 groups of 8 groups of 3, and there's 24 dots. 9 groups of 3, and there's 27 dots. 10 groups of 3, and there are
30 dots.
30 dots. So we can say 10 times 3 equals 30, and so on. So that's a nice way to look at the 3 times table. And anytime you're studying the 3 times table, I would be drawing this. This is called an array. What we're doing, we're drawing an extra 3 each time. So it's a really nice way to study the 3 times table. And then we can say, okay, let's count forwards in 3s. So are we ready? We're going to count forward in 3s. So we start at 3. So we'll go 3, 6, 9, 12,
15, 18, 21, 24, 27, 30.
Good, and then we can maybe start counting backwards in 3s. So we can go 30, 27, 24,
21, 18, 15, 12, 9, 6, 3, 0.
Well done, I've not got 0 in there. Well done, Austin, that's good. So counting forwards in 3s and backwards in 3s is a really important skill, making sure we're asking. And then what I would do here is maybe now we can start introducing the stations of the three, or the three times table. So 1 times 3 equals 3, 2 times 3 equals 6, 3 times 3 is 9, 4 3s are 12, 5 3s are 15, 6 3s are 18, 7 3s are 21, 8 3s are 24, 9 3s 27, 10 3s 30. So this is the way I would introduce the 3 times table. And I would be constantly referring back to what we're doing as well. Counting in threes, or we're skip counting in threes. We're adding on 3 each time. Oops, sorry, I didn't mean to go in there. So 1 group of 3, if you can see here, 1 group of 3, 2 groups of 3. It's the number of groups that's changing, but the amount of 3 in each group is remaining the same. So this is the way I write my tables: 1 times 3, 2 times 3, 3 times 3, 4 times 3. So it's the number of groups of 3 that's increasing. So this 3 here is staying the same. So we're talking about the groups of 3 increasing. So again, it's referring back to repeated addition or counting on in threes. And then we can ask ourselves some random questions about the 3 times table. What is 7 times 3? Right, don't shout this out. Listen, I'm going to ask, what is 7 times 3? Everyone at home, hope you're shouting this out or typing it in. What is 7 times 3? Do you know the answer? Type it into the box. Shout it out at home, Austin. Shout it out.
21.
21. Now we might say, what is 9 times 3? Shout out the answer. What is 9 times 3? Austin?
27.
27. And we can ask ourselves, what is 4 times 3? What is 6 times 3? What is 8 times 3? What is 3 times 3? You'll notice I haven't got the numbers down the side here to help me. Obviously, we could have them there if we need them, but it's sometimes good to practice without that as well. And then we might say, okay, as I just say, keep asking yourself all these questions about the 3 times table. Practice makes
Perfect.
Practice makes better. That's my statement. Practice does not make perfect. Nobody's perfect. So my saying is practice makes better. And then we might say, well, okay, how many 3s make 15? How many 3s are in 15? What is 30 divided by 3? What is 6 divided by 3? What is 3 divided by 3? So we can ask ourselves these type of questions. So how many 3s make 15, Austin?
5.
5. What is 30 divided by 3? So that means how many 3s are in 30?
10.
So you can ask yourself these questions as well. Again, there is the answers at the side there to help you if you need them. I'm just going to quickly stop and see if I've got any questions coming through on the chat box. No questions just now. So every now and then I will stop and check my phone to see if there's any good questions coming through. So if you have any questions to ask me or any of the people, the panel behind us, put them into the chat box. I will get the kind of key questions forwarded to me. Hope you're enjoying it. If you are enjoying it, remember, let's see some pictures of the children and yourselves on Twitter. Hashtag is NPFSmath. So good question, yes. So Julie, should we stop at 3 times 10 or sorry, should we stop at 10 times 3 or keep going to 12 times 3? I think a lot of the times, and my answer to that would be we never stop. We never stop. So I've deliberately stopped at 10 times 3 because you'll see what I'm going to teach later on. I don't like a lot of the kind of charts and stuff like that in classrooms go to 12 times 3, and I can understand why, but I don't like that, to be honest. So I deliberately stopped at 10 3s, but I'll show you my method for doing further calculations later. So thank you very much, Julie. That question will be answered as we go on. So I hope that, as you see, that I'll answer your question later on. Any more questions? Keep them coming through. Thank you, Julie. So something like, what is 18 divided by 3? Just a quick wee point here is what we can always do is when we're thinking of 18 divided by 3s, we can relate that to the multiplication. So although we're thinking 18 divided by 3, we're thinking how many groups of 3 or what times 3 equals 18. So always have that wee link with your multiplication and division. I've got another question coming through. Would you always start talking about division at the same time as multiplication? Yeah, I think it's important, Susan. They all link in together. So maybe when I flick back a couple of screens, I was maybe not the first question you can see here. I was saying how many 3s make 30, or how many 3s are in 21. So maybe not mentioning the word division straight away, but talking about how many 3s make 24, or how many 3s are in 12, things like that. But yeah, I think it's important to always establish that multiplication and division are pretty much, they're connected, they're the same process, and that's important to establish that right at the very start. Hope that answers your question, Susan. Thank you. So I say here, what is 18 divided 3? Well, we can relate that to multiplication. How many 3s are 18? We can draw the picture. We can see that that answer was 6 groups of 3. So 18 divided 3 equals 6. What is 7 times 3? Well, again, if any time I was asking a question and I couldn't quite remember or recall the answer, then always go back to the explanation or the visual clues. What is 7 times 3? What does that mean? What does it look like? Well, it's 7 groups of 3, so we're going up in 3s. We're counting in 3, 6, 9, 12, 15, 18, 12. So anytime you're stuck with a multiplication, draw the picture, reinforce yourself or remind yourself exactly what multiplication is all about. Draw the picture, make that connection with your brain. The more times you draw the picture, the better, the more you understand it, the more confidence you'll gain, and the more that'll commit to your long-term memory. So I just want to point out, what is 7 times 3? Well, I can also see 7 groups of 3, but what I can notice here is that's a column of 7 yellows, a column of 7 blues, a column of 7 reds. So if I repeat that over here, we can actually see 7 times 3, just like we mentioned earlier on, that's the same as 3 times 7. Now, if you're interested, that's called the commutative law of multiplication. Basically, 7 3s is equal to 3 7s. And just what kind of Julie was, sorry, was Susan was saying here, these connections we can say, so 7 times 3 equals 21. 3 times 7 equals 21. 21 divided by 3 equals 7. 21 divided 7 equals 3. So all these things are connected. So that's why it's important when you're talking about multiplication division, it all comes from, you can get all that information and all those connections from that one picture here. Okay, hope we're having fun. Remember, let's keep the comments coming through in the chat box. Let us know how you're getting on at home. Are you having fun, Austin?
Yeah.
Yes, good. Okay, another thing we can also do is we can look at our skip counting in 3s, or the stations of the 3 times table on the 100 square. So if I start to map this out, we can say 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And I've stopped at the 10th station here, just to have a wee breather and say, well, now you could continue the pattern as far as you can in 100 square. You might have already started to spot the kind of diagonal pattern here. And if I continue that on, you can see, look at the very nice pattern that 3 times table has. You might ask, why are these red? Because this is 10 groups of 3, 20 groups of 3, 30 groups of 3. As you can see in the first row here, 3, 6, 9, 30, 60, 90. So that kind of pattern would start to emerge here as well. Okay. Now, what I would say again, I mentioned it earlier on, anytime you're looking at the 3 times table or studying the 3 times table, practice by drawing the 3 times table over and over again. Maybe draw it on a daily basis, or maybe draw it 2-3 times a day till you really get that familiar pattern, what's happening. And look at the links. What does 7 times 3 look like? Well, you might look at 7 times 3 and say, well, actually, it's 5 groups of 3. I know 5 3s are 15, and it's just an extra 2 groups of 3, so it's 15 adds 6. That's a good way to learn 7 3s. Maybe know 5 3s are 15, and you can just add 6. Or you can count on from 15. Well, I know 5 3s are 15, so if I go 18, 21, that gets me the answer as well. You might look at a question, what does 8 times 3 look like? Well, you might see it's double 4 times 3. So you can see it within the 8 times 3 picture, it's 4 3s plus another 4 3s, so it's double 12, or it's 12 plus 12, so it equals 24. So that's another way to kind of look at connections and think about what does 8 times 3 look like, or just patterns within the 3 times table. Another, again, you might think, what does 9 times 3 look like? Well, you might say, well, actually 9 times 3 is 10 groups of 3 just with a group of 3 missing. And that's like 30 with 3 off it, or 30 subtract 3, so it's 27. So there's lots of patterns and connections you can make by drawing the table out, drawing the 3 times table out on with the 3 dots and the array, and look and see exactly what's happening and study it and look for patterns. Right, so I'm just going to stop here, just check, see if there's any more questions coming through. How are we all getting on? Good. What I want to do is just remind you, let us know how you're getting on. The hashtag NPFS Maths. If you have working with your children, let's get pictures on Twitter and let's see what impact this is having for you guys. Okay, next one, what we're going to do, we're going to look at, how many dots are there? 4. And there is 8, 12, 16, 20, 24, 28, 32, 36, 40. And you can see here, this is the 4 times table. Oops, it's going crazy here ahead of me. So here we're counting up in 4s, or we can count backwards in 4. So here again, I'm not going to spend a long time looking at this, but this is how I would look at the 4 times table. Again, just looking at drawing the dots out. So 1 group of 4, 2 groups of 4, 3 groups of 4, and so on, and reciting the answers, 5 groups of 4, 6 groups of 4, 7 groups of 4, and so on. So, and again, once we've done that, we can introduce the tables. 1 group of 4 is 4, 2 4s are 8, 3 4s are 12, and so on. So that, again, similar to the 3 times table, we can draw the 4 times table like that and look at the patterns. And again, count forwards in 4s. We can count backwards in 4s. And again, we can ask ourselves similar questions about the 4 times table. What are 7 4s? What are 9 4s? What are 4 4s? What are 6 4s? What are 8 4s? What are 3 4s? And so on. And I might say, okay, how many 4s make 20? What is 40 divided by 4? What is 8 divided by 4? What is 4 divided by 4? We're not going to spend much time answering all of those questions. Yeah, again, this is something I want to try and put as much information into this one session as possible. So this is something that you can maybe try again later. You know where the slides are at. I'll put that link back on at the end as well. And again, this is some of the tasks that we have at the end on the website. Some context or word problems here. There are 8 people in the rugby club. Each week they pay the rugby coach £4. How much money does the rugby coach collect? How much money does the rugby coach collect each week? So you need to think, what type of calculation is that? Well, if they're all paying £4 and there's 8 people, that's going to be a multiplication. So it's 8 4s.
8 4s, 32.
£32. Question 2, a golf shop has, sorry, that's not worded properly, I'll fix that. A golf shop collects 18 golf balls, they sell them in packs of 3. How many packs of 3 do they sell? So if I've got 18 golf balls and I put them into packs of 3, how many packs is that? So what type of question is that, or what type of calculation do you need to do? So you can see here, if I've got 18 golf balls and I put them into packs of 3, I want to find out how many packs of 3 that is. So that's a division. So 18 divide 3. So the answer would be 6. But again, that's in the task at the end, and there's more questions like that for you to try. So what next? What if you have learned all of your tables? So imagine now you have learned your 3 times table, your 4 times table, your 5, 6, 7, 8, 9 times table, 10 times table, 11 times table, 12 times table. You're thinking, hey, what?
You want to say your 13 times table?
You could go to your 13 times table.
Like me.
Have you done your 13 times table, have you?
No.
Good. That's not what I'm going to do just now, but what I'm going to look at is kind of more like the question that someone asked earlier on. Would you go on to 12 or would you stop at 12? So that's what I'm going to look at now. So again, we're trying to cater this session for first and second level. So some people might be at the stage where they just want to go and study the 5 times table, the 6 times table, and they might not be ready for what's coming next. But I suggest that you all stay on, because I think you'll find what I'm about to show you is really, really beneficial for what's coming in. And it's actually, if you know the first 10 stations of the 3 and 4 times table and so on, then this next bit is really easy as well. So stay on board here and let's see what can we do to challenge ourselves, and what's the next step in the progression with multiplication and division. So let's look into the 3 times table in more depth. So again, I'm just going to flick back to this question that Julie had asked. Should we stop at 10 or should we stop at 12? Well, let's just see. So my question is to you, how many groups of 3 are there now? So how many groups of 3 are on the screen now? Type an answer into the comments box, shout it out at home. How many groups of 3? Now listen to the question. How many groups of 3 are there? Austin, how many groups of 3 are there?
20.
20 groups of 3. How many dots is that?
60.
60. So we can say 20 groups of 3 equals 60, or 20 times 3 equals 60. What is 60 divided by 3?
20.
20, good, because that's how many groups there are. How many 3s are there in 36? So that's a bit like Julia asked earlier on. So how many 3s are there in 36? Well, what I need to do is I need to identify 36 dots. So I can see how many dots are in this section here, Austin?
30.
30. I want 36 dots. I'm looking at this question 5. How many 3s are in 36? So I've identified 30 dots. I need an extra 6 dots. So how many 3s is that? Well, you can see there's 10 3s in here, and there is 2 3s in here. So we can see the answer is?
12.
12. So there are, how many 3s are in 36? There are 12. Okay, next. How many groups of 3 are on the screen now? Don't shout out, Austin. How many groups of 3 are on the screen now? Type in the answers. Shout it out at home. How many groups of 3 are there? How many dots are there? So hopefully, Austin, how many groups of 3 are there?
30.
30 groups of 3. How many dots are there?
90.
What is 30 times 3?
90.
What is 90 divided by 3?
30.
30. How many 3s in 63? How many 3s are there in 63? So basically, we're thinking, what number times 3 equals 63, or how many groups of 3 are there in 63, or 63 divided by 3? So what I'm going to do is I'm going to highlight 63 dots again. So how many dots is in that yellow bit?
30.
30. How many dots is in that yellow bit?
30.
So how many are in the yellow bit just now?
60.
So how many more do I need? 3 more. So we can see that I've now highlighted 63 dots. There is 10 groups of 3 in here, 10 groups of 3 in here, and 1 group of 3 in here. So how many 3s are in 63, Austin?
21.
21, good. So this is what I was talking about, Julie, about stopping at 3. You asked the question about should we stop at 10 3s or 12 3s. I would never stop, but I would use kind of this picture here to help me do all sorts of calculations, and you'll see what I mean just as we progress through these next slides. Let me know how this is going, please. Any questions? Very important to ask questions. I'm sure if you've got a question to ask, everybody else will be thinking that same thing as well, or a large group will be thinking about that. So please pop the questions into the comments box and they will be forwarded to me. So we're going to use this to work out 14 times 3. Because as we can see here, I have 10 groups of 3 here, and I've got 4 groups of 3, so I've got 14 groups of 3.
Mm-hmm.
Right. So here's 10 3s, which is
30.
30. That's 4 3s in there, which is
12.
12. So 14 times 3, what's the answer to that?
42.
How did you get that?
I added 32 and 12 together, what gives me 42.
Yeah, I did the 30 and the 12 together to get 42.
Mm-hmm.
So we can see here, we're using this picture to work out 14 times 3. So it's basically my 10 3s plus my extra 4 3s. So it's 30 plus the 12, which equals 42. And again, that's why I wouldn't, this is my method for working out all the multiplication. I wouldn't stop at 12. I wouldn't stop at 10. I would just be thinking of, well, basically it's 10 3s and it's an extra 4 3s. I know 10 3s are 30. I know 4 3s are 12. I know how to add 30 and 12. So I know the answer is 42. I want to record this in a different way. So this is obviously using the dots and the arrays. But there's a nice way we can record this called a bar model. So what did I do earlier on? I split the 14 groups of 3 into 10 groups of 3 and 4 groups of 3. So I want you to draw this out at home. So draw a bar like that, 14 by 3. So this is what we call a bar model for multiplication. So can you draw a bar at home, 14 by 3? And what I'm going to do with that 14 is the same as I did in the previous screen. I'm going to split the 14 up into 10 and 4, because 10 plus 4 is 14. So I'm splitting the 14 groups of 3 into 10 groups of 3 and 4 groups of 3. 10 times 3 was 30, so let's put 30 in there. 4 times 3 is 12, so we put 12 in there. And we can see 14 times 3 is the 30 plus this 12, so the answer is 42. Now that's just a different way to record that strategy there without having to draw out all the dots every single time, which you might say this is more efficient long term. So this is maybe where I want children to get to, a point in their learning where they don't have to always draw the dots. They can use this bar model method for quickness. And again, the more they practice this, the more it becomes part of the long-term memory, the more they understand it, and the more they can use it as a mental math strategy. This is also called the area model, sometimes, like linking it to the area of a rectangle and so on. And again, what we did, we partitioned it to make the multiplication easier. So I split the 14 up into 10 groups of 4 and 10 groups of 3 and 4 groups of 3 to make, and it's called place value partitioning because we split up the 14 into 10 and 4. I'm just going to point out 30 is a key number when dealing with 3. So 30 is a key number when dealing with 3. Next question, how many groups of 3 do you see on the board, on the screen, sorry. How many groups of 3 do you see on the screen? How many groups of 3 do you see on the screen? Hopefully, you can see this is 16 groups of 3. We have 10 groups of 3 and we have 6 groups of 3. How many dots are in this section here? There are 30. How many dots are in this section here? There are 18. So we can see 10 threes are 30, 6 threes are 18. So to work out 16 times 3, we do 30 add 18. So the answer is 48. Again, I'm going to record this in the bar model. So 16, so obviously there are other ways to do 16 times 3, but I'm going to focus on this strategy for today. So you might have different ideas, which is great, but for today I'm going to focus on this strategy. Excuse me. So let's draw a bar model for 16 times 3. So let's have my bar, which is 16 by 3. So let's draw that out at home, a quick rectangle, 16 by 3. What did I do to that 16? Well, we split it up into 10 threes and 6 threes. So I'm going to do the same over here. Split that up into 10 and 6. In this bit here, we're going to write the answer to 10 times 3. So 10 times 3, how many dots were in the 10 times 3 bit? There was 30. How many dots were in the 6 times 3 bit, Austin?
18.
18. Get the answer to 16 times 3, what do I do?
Add 30 and 18 together.
To get?
48.
48, good. So again, that ties in really nice with that picture there of 16 times 3. We don't have to draw out the dots for this bar model method. So eventually this will become a very efficient method to do the calculations. Again, we're partitioning the 16 into 10 and 6 to make the multiplication easier. Again, 30 is a key number when dealing with 3. Right. We're going to use this to work out 26 times 3 now. So I want to highlight 26 groups of 3. How many? Whoops. So I'll have 10 groups of 3, then another 10 groups of 3, and then 6 groups of 3. How many dots are in this bit?
30.
30. How many dots are in this bit?
30.
How many dots are in this bit? 18. So you can see I've split the 26 times 3 into 10 times 3, 10 times 3, and 6 times 3. And we can see 10 threes are 30, 10 threes are 30, 6 threes are 18. We're ignoring these dots that are not in the yellow box here. So let's use the bar model to represent this calculation. So we've got my bar model here. So draw me a bar 26 by 3. And I split the 26 up into 10, 10, and 6. So we can see 10 times 3 was
30.
30. 10 times 3 was
30.
30. 6 times 3 was
18.
18. What do I do with those numbers to get the answer to 26 times 3?
You add 30 and 30 together, what equals 60. Then you added 18 on, what gives you 78.
Well done, Austin. Good. So remember, all of these slides are going to be on our website that I showed you at the start. You can download that and you can look back over these slides. You can take your time. You can go through them. You can, remember, if you've got any questions to ask, even after this session, you can ping us a message on Twitter. You can include the National Parent Forum in that question. You can tag Education Scotland. You can tag Making Maths Count, and there will be somebody out there who will answer you within 10 minutes, because there's lots of educators out there, teachers, that are just desperate to help people. So please, if you've got any questions about any of these slides, obviously you ask us on Twitter, but you may get help from other people as well. If you've got any questions right now for me, please ask them. We're a wee bit late in starting, so we might run on a wee bit late, so please stay involved. It's about to get really fun. We're going to look at some division strategies in just a wee minute. Okay, let's get going for the next example. So again, 30 is a key number when dealing with 3. So let's look at a multiplication involving 13 times 4. So what I want is I want 13 groups of 4. How many groups of 4 do I have on the screen right now? I only have 10 groups of 4, so I need an extra 3 groups of 4. So that's 1 group of 4, 2 groups of 4, 3 groups of 4. Go back to the question that Julie was talking about earlier on. If I want to work out 3 times 4, I would just say, well, it's 10 times 4, and I need to go on 4, 8, 12. I need to go on another 4. I can start at 40 and count on in 4s from there. So 13 times 4, you can see I've got 10 4s and I've got 3 4s. In here I've got 40 dots. In here I've got 12 dots. So I can see it's 40 plus 12, so the answer is 52. So let's look at this on the bar model. So 13 and 4. So can you draw this bar model for me? 13 times 4. And what did I do to the 13 groups of 4? Well, I had 10 groups of 4 and I had 3 groups of 4. So I'm going to do the same over here. I'm going to split that up into 10 and 3. 10 4s, how many dots are in the 10 times 4 bit, Austin?
40.
40. I'll just give you a wee minute to catch up back home, just to make sure you're doing this. So that's 10 4s in there, which is 40. And let's just quickly look back to the other page. Okay, there's my 13 groups of 4. There's my 10 groups of 4. There's my 3 groups of 4. That was 40 dots in there. I can see if I read across, that's 12 dots. So we're 10 4s. So we're splitting the 13 up into 10 and 4. Sorry, 10 and 3. 10 4s are 40. 3 4s are 12. To get the answer, I do 40 add 12 gets me 52. So that's how we're doing 13 times 4. Again, 40 is a key number when dealing with 4. So 30 was a key number dealing with 3. 40 is a key number dealing with 4. Let's look at 17 times 4. Now this time, I'm going to go straight to the bar model. Okay. So I'll get you to draw that bar out just now. I'll just stop and see if there's any questions coming through. Remember, if you're, let us know how this is going. We're obviously at a kind of more complex level of multiplication just now. Hopefully you're finding this useful and you're finding it a good strategy to use. So 17 times 4, so I'm not going to draw the dots out this time. I'm just going to say, right, what did we do previously? Well, we split the 17 up into, what do you think, Austin?
10 and 7.
Good. I would always go for 10 and 7 in this type of question. You don't always have to, but I particularly would. So, and then I say, right, let's split the 17 up into 10 and 7. So let's draw this bar out at home and say, okay, right, what are 10 4s? What number is going to go in? What's 10 times 4, Austin?
40.
40. So I'm going to put that in there. So that's 10 times 4. And in this bit here, we're going to do, well, this is 7 times 4. Do you know what 7 times 4 is at home? If you do, write the answer in this bit here, 7 times 4. Austin, what is 7 times 4?
28.
28. And how do I work out the answer, Austin, to 17 times 4?
You add 40 and 20 together.
You add 40 and 28 together to get?
68.
Good, 68. Well done. And that's how I would do 17 times 4. Again, 40 is a key number when dealing with 4. I'm going to skip by this one just now, but I'll just point out if I'm dealing with 5, I end up with 50 being a key number. I'm going to skip by this one because I realise just we're a wee bit tight for time. So here is an exercise you can do at home. Basic set, intermediate set, extension set. This is on the website. So again, I'll give you the link to that. I'll give you a link at the end, so you can try that out after this session. But what I want to do just now is I want you to talk about the same strategy for division. So if you like that strategy for multiplying, you can use this strategy for division. So we just need to understand these key things. When dividing, we just need to understand each number has a key number. When dividing by 3, the key number is, so we mentioned earlier on, 30. When we're dealing with 4, when dividing by 4, the key number is going to be 40. When dividing by 8, the key number is going to be
80.
80. And when dividing by 6, the key number is going to be
60.
60. If I was dividing by 13, the key number would be
130.
130. Okay, so quickly do a couple of examples of this. So 51 divide 3. Because I'm dividing by 3, we talked about earlier on in the multiplication, 30 is a key number. So I want you to draw a bar, I want you to put 51 in the middle, and I want you to put 3 at the side. And when dividing by 3, the key number is 30. So what I want you to do is actually rub out that 51 now, because what we're going to do is we're going to split this bar up into 2 different bits. So it's still 51 in size, but I want to split it up into 2 bits. The first bit is 30 because that is my key number. Now, if the first bit is the key number of 30, the other bit must be 21 because 30 plus 21 equals 51. So although, like this is 51, all I'm doing is breaking up the 51. I'm rubbing it out and I'm breaking the bar up into 2 different bars. The first bit's 30, which means the other bit must be 21 for it still to equal 51. Now I'm going to divide 30 and 21 by 3 separately. So instead of dividing 51 by 3, I'm going to divide these by 3 separately. So 30 divided 3 equals 10. 21 divided 3 equals 7. So therefore, 51 divided by 3 is this 10 plus that 7. So it's 17. Got that, Austin?
Yeah.
51 divided 3 equals 17. And again, I partitioned the 51 into the key number of 30 and 21. It makes the division easier for me. So I just need to understand that 30 is the key number. Any questions, please pop them in. I'm going to do a couple more examples of this. Again, these slides, this is recorded, it'll be on YouTube. You can watch it again to just go over some of the key points. And again, you could link that to 51 divided 3. How many times 3 equals 51, or how many groups of 3? So you're linking it to the multiplication. Or again, look at those pictures. That's 30 dots. That's 21 dots. I can see that's 10 groups of 3. I can see that's 7 groups of 3. So I can see 17 groups of 3. So again, linking it to that picture of, I just need to make 51 dots. And I can see clearly what the answer is. Okay, so let's look at another question. Let's say we're going to do 72 divided by 4. So if I'm going to do 72 divided by 4, I want you to draw a bar. I want you to put 4 at the side. I want you to put 72 in the middle. Okay, and if we're dividing by 4, what is the key number, Austin?
40.
40 is the key number. So 40 is the key number when dealing with 4. So that means I'm going to split this bar up into 40. And what must the other bit be? Then remember, it was 72 to start with, but I'm splitting up into 40. And what must the other bit be, Austin?
32.
Good, the other bit must be 32 because it still needs to equal 72 altogether, and 40 plus 32 equals 72. And then what I'm going to say is, like, what is 40 divided by 4? Oh, how many 4s make 40? The answer is 10. 32 divide 4, so we're again must dividing these, instead of dividing 72 by 4, we can divide these two numbers by 4 separately. So 32 divide 4 equals
8.
8. So that means that 72 divide 4 is your 10 plus your 8, which is
18.
The answer is 18. So 72 divide 4 equals 18. Again, if partitioning the 72 into key number of 40 and 32 makes the division easier. I just noticed a question come through, so I'm going to answer this now. Yeah, so good question, Joe. So you can use that. So if you didn't know, so let me just stop this here. Yep. I'll try sharing the other screen here. Hope you're all having fun. Let me just try my new device here. So Joe's asking a question. So if you were going to do something like, yeah, well, it's not a very good bar, but I'll try my best. So say you're going to say, what is 21 divided by 3? And you weren't quite sure about it, just like we mentioned earlier on, but you do, well, actually, I'm dividing by 3, so I'll put 3 at the side. I do know what 15 divided by 3 is. So 15 plus what gets me 21? Well, actually 15 plus 6. So what I can do is I can split I can partition the 21 into 15 and 6. What is 15 divided by 3, Austin?
5.
5. What is 6 divided by 3?
2.
So we can see, right, all I have to do is add the 5 and the 2, so the answer is 7. Yeah, good question, Joe. Thank you for that. Any other questions? Please pop them into, I'll just check just now before we go back. No more questions. So yeah, you can do that. Now I realise the time is getting on. We still have a lot of people on. I'm going to do 1 or 2 more examples, and then we'll get you to do the survey. So apologies, it's kind of going on slightly, so I'm a little bit later getting started. I'll quickly do 1 or 2 more examples, and then you can do the evaluation and you can try to work out the task set. So here we go. So say I want to do 45 divide 3. I want to draw out the bar model. I've got 3 at the side of 45 middle. When I'm divided by 3, what's the key number?
30.
30. So I split that up into 30. What's left over for the other bit?
15.
15. And then let's divide 30 by 3 equals
10.
10. 15 divided 3 equals
5.
5. 45 divided 3 equals